Yes, hello folks, we are there now with the part 5 video. Hopefully this should be the last video depending on how voluminous these problems are. So let's get across directly. We have this 10th and the 11th problem to do. I don't know how it is going to work out, whether it is going to be voluminous and all that. We will see how it is coming. So we have this problem number 10 which has some specific function for x and some specific function for y. So right away let's find the derivative as we always do. So let's consider the x first. Consider x as a cos theta plus a theta sin theta. There's a product here. So getting the derivative with respect to theta means it is d by d theta of this whole thing. Or in other words, it is d by d theta of a cos theta and d by d theta of a theta sin theta. Without doubt, this a will come out in both the cases. So you have a d by d theta of cos theta here, and this is a d by d theta of theta sin theta. Now this is a product, so you have to treat it as a product. A times d by d theta of cos theta, and here it is a times, let's treat it as a product, theta times derivative of sin theta plus sin theta times derivative of theta. Now let's see what is coming. Cos theta we know is minus sin theta, then a times theta into sin theta, derivative is cos theta, sin theta, and derivative of theta with respect to theta is 1 itself. So this is how it is. Let's open this up. Minus a sin theta plus a theta plus a sin theta. Luckily for us, the plus a sin theta and minus a sin theta, they cancel in each other and we are left with a theta. Right. So it's a theta value that is there with us. So for dx by d theta. On the same lines, we will also find dy by theta. Also, y is a sin theta minus a theta cos theta. Now because we are a bit experienced here, we can jump some steps and we'll get like dy by d theta is a times d by d theta sin theta, a times d by d theta of theta cos theta. So a into d by d theta of sin theta minus a into theta times derivative of cos theta minus cos theta into derivative of theta. So cos theta we know, sin theta we know derivative is cos theta. This is a times cos theta, derivative is sin theta, and cos theta, derivative of theta of course is 1. Now what comes here? A cos theta plus a theta sin theta when we sort out the signs. And yeah, why is this minus coming? Because we are in product too, no? Yeah, so it is minus a cos theta. Can cancel. We are left with a theta sin theta. So we are done. We have got dx by dt also. We have got dx by d theta also. We have got dy by d theta also. So we can get dy by dx. How? Dy by d theta whole by dx by d theta. So that is a theta sin theta. This is a theta. They both can cancel. Your answer finally is sin theta. Let's take this. Oh, yeah, see here, a theta cos theta. We missed it. Right, so that cos theta is there, so that cos theta is there, sin theta by cos theta is tan theta. Right, so that's the answer. Answer becomes tan theta. That was, say, better problem. Now let's see, this looks voluminous. I don't know how it is going to be like. So like every time that we do, we'll start right away with x. First let's consider x. The x is root of a raised to sine inverse t. Now it's all complicated, right? So we have to reach to dx by dt. So we'll make substitutions and we'll see how. So first let's have say u as sine inverse t. then we can have v as a raised to u. So x will become root. So u a raised to u, that is v, and root. Yes. Now derivatives. Du by dt. Derivative we know for sine inverse it is 1 minus t square. dv with respect to du is a raised to u. dx with respect to dv is 1 by 2 root v. We know it. That root x is 1 by 2 root x derivative. So that way. So like that we will try to reach dx by dt. How? dx by dv, dv by du and du by dt. 1 by 2 root v. dv by du is, wait. A raised to u log a. Yes. So a raised to u log a. We've done that on the first day itself. Then of derivatives. Yes, so du by dt is 1 by root of 1 minus t square. So we have to revert back everything in terms of t. So 1 by 2. b for us is a raised to u, which is a raised to sine inverse, or okay, let's have it as a raised to u. This is also a raised to u log a. See, here can you see the thing? 2 root of 1 minus t square root a raised to u log a. So log a into root of a raised to sine inverse x by 2 root of 1 minus t. Okay, so that's when we revert back and get everything in terms of t. dx by dt is done. Now let's come back. Actually dv by dt everything will be same except for this. Okay, let's quickly do it. Consider y equal to root of a raised to cos inverse t. Let u be cos inverse t, v be a raised to u, and w be, and y be root of v. So we have this first we will write like that. A raised to u log a dy by dv 1 by 2 root v and du by dt minus 1 by 1 minus t square. So actually your answer is going to be exactly same except for a minus. There will be one minus there. So like we can have all the patience to sit and do it, but I will get it directly. Dy by dt by all this only. I'll just give you the formula and I'll be over smart in writing it first. Dy by dv, dv by du and du by dt. You are going to get minus log a root of a raised to cos inverse t by 2 root of 1 minus t squared. Okay. So what will happen to your dy by dx? It will be dy by dt by dx by dt. And what are these? These are minus log a root of a raised to cos inverse t by 2 root of 1 minus t squared whole upon. Log a root of a raised to sine inverse t 2 root of 1 minus t square. I have told you numerator, denominator. So numerator cut, denominator cut. What are we left with? Minus root of a raised to cos inverse t. Sorry. A raised to cos inverse t by a raised to sine inverse t, which is they tell us. Okay, they tell us, yeah. So this is y and this is x, minus y by x. Actually it's a prove that question saying that show that this is minus y by x and this is how it is, minus y by x. So that's all about the exercise. We finish exercise with this. In the new part we come with the new video. Thank you, and new exercise.